Hello, and welcome to Business Calculus Derivative Applications. What we would like to do in this video is look at a couple of examples that have to do with the basic problems of calculus that we introduce when we introduce the idea of a derivative. First, let's look at a problem concerning instantaneous velocity. Suppose that an object is moving along the y-axis with units of meters so that its position at a time x, given in seconds, is provided by the function f of x is equal to x cubed minus 6x squared plus 9x. We would like to do the following three things. 1. Find the instantaneous velocity function v. Find the velocity at x equals 2 and x equals 4 seconds. And find the times when the velocity is equal to 0. So let's work this out. Our instantaneous velocity function is, of course, equal to the derivative of our function f. So we take the derivative of each of our terms, getting 3x squared minus 6 times 2x plus 9. And we can simplify this to be 3x squared minus 12x plus 9. All right. Now moving on to part 2, we want to determine the velocity at x equals 2 and x equals 4 seconds. In order to do that, all that we need to do is evaluate our velocity function, f prime, at each of those values. So we get 3 times 2 quantity squared minus 12 times 2 plus 9. 2 squared is 4 times 3 is 12. Negative 12 times 2 is negative 24 plus 9 is going to be negative 3 meters per second. In order to determine the velocity at 4 seconds, we plug 4 into our derivative function. We get 3 times 4 squared minus 12 times 4 plus 9. 4 squared is 16, so we have 3 times 16. 12 times negative 4 is 48. And then plus 9. 3 times 16 is 48. So 48 minus 48 is 0. Plus 9 is 9 meters per second. And lastly, we want to determine when the velocity is equal to 0. That means that we want to set v of x, or f prime of x, equal to 0 and solve. F prime of x equals 3x squared minus 12x plus 9 equal to 0. We would like to factor out a 3 to make this easier to work with. So we get 3 times x squared minus 4x plus 3 equals 0. And we see that x minus 1 times x minus 3 is the factored version of this function, which tells us that the velocity function is 0 when x equals 1 and when x equals 3. For the second example involving our basic problems of calculus, we would like to look at tangent lines. We want to find the tangent lines of the function f of x equals x to the 4th minus 5x squared plus 12 by doing the following. We're going to determine the derivative function f prime. We're going to find the equation of the tangent line at x equals 1, and then we are going to determine the values of x where the tangent line is horizontal. All right, let's start by calculating our derivative. F prime of x is equal to x to the 4th prime minus 5x squared prime plus 12 prime, which is equal to 4x cubed minus 10x. And the derivative of 12 is 0 because it's a constant, so we just have 4x cubed minus 10x as our function. What we would like to do now is to find the equation of the tangent line at x equals 1. Let's start by writing down the calculus version of the slope-intercept form of the equation of a line. We get y minus f of x naught equals f prime of x naught times x minus x naught. Now, in this case, the point that our line is passing through is x naught, f of x naught. And in our case, x naught is equal to 1. And the slope of our graph is equal to the derivative of the function at x naught. So let's start calculating these values. F of 1 is equal to 1 to the 4th power minus 5 times 1 squared plus 12. And we get 1 minus 5 plus 12, which is 8. All right. Next up, we want to calculate the value of the derivative at 1, and we get 4 times 1 cubed minus 10 times 1, and 4 minus 10 is negative 6. These pieces of information, we can plug in the values to our slope-intercept form of our equation and get that y minus 8 is equal to negative 6 times x minus 1. We'll go ahead and rewrite this over here as y equals negative 6x plus 6 plus 8, adding 8 to both sides and distributing my negative 6. And that leaves me with, lastly, my equation of my tangent line as negative 6x plus 14. To finish up, we would like to find the values of x where the tangent line is horizontal. So that means that we want to set our derivative equal to 0, because a horizontal line has a slope of 0, and since the derivative of a function measures the slopes at all the points, that tells me where our horizontal lines are. So we get 4x cubed minus 10x equals 0. And in order to find where this is 0, we're going to go ahead and factor it. So we write it as 2x times 2x squared minus 5 equals 0. And that allows us to treat this as two separate problems. 2x equals 0, which clearly tells us that x equals 0 is an answer. And 2x squared minus 5 equals 0, which tells us that x equals plus or minus the square root of 5 halves is an answer. What I'd like for you to do now is to use what we have just learned to find the equation of the line tangent to f of x equals 2x squared minus 3x plus 5 when x is equal to 2. Here are some potential equations for your tangent line. And I would like to thank you very much for listening.